Hi again, everybody. This is Jason Nemro, doing it cheap just because that's the only way I know how to do it. Hi. We're going to talk about, we're going to take a little tour of hardware. And first thing you got to know is that all computers are almost exactly the same. They will have all the same pieces in it. Processing, you guys have already seen this, but you'll see it again if you watch the first video that's mostly just the PowerPoint with me yakking away. You'll see the breakdown of how computers are. This is the actual tour, so you can take a look. This wonderful little board was actually pulled out of a point of service system, which you can learn about more in your chapter. A long time, actually it never got itself into a point of service computer. This is actually a fully functional computer. It's good because you can actually see the individual parts. If I take you over here to an actual desktop that's been opened up so you can see the innards of that, it's hard to see what's going on, so we're going to show you what's going on over on the nice computer, over on the nice board over here. All the same parts, almost completely the same. Anyway, so let's start the tour. The tour begins with the central processing unit, which is where everything happens. It's this wonderful little silver thing here. This is, I think this was made by National Semiconductor. It's a geode. It's an IBM PC compatible semiconductor right there. Not very powerful compared to the one things, but the great thing is you can actually see it. Let me take you over to the other one. You can't see the CPU on this thing if your life depended on it, unless I started ripping and tearing this thing. The CPU is actually, you see this heat sink over here, this little thing with blades right there is called a heat sink. There's a fan on top of it, as you can see. You can see another heat sink here so you can get kind of a better view of it. The CPU is actually buried way under the heat sink because most microprocessors put out a ton of heat. This one over here, which is our one that we're showing you everything on, it doesn't put out much heat at all. Therefore, you can actually see the thing. Usually you would have some gel on top of this and you put a heat sink on top of it and then a fan on top of that to try to cool this sucker down because they get hot. Alright, so you always start with your CPU. Now the modern CPUs actually have some, well, you know, let's not go into that yet. We'll go into that in a minute. Okay, every computer has to start with a little bit of memory, just a touch, just to keep it going. The memory that we have is actually underneath this little sticker. It's a little chip here. It's called ROM, read-only memory. And on most computers these days, it's really hard to find because it just looks like any other chip on there. It could be that chip, it could be that chip, it could be this chip, but it's not. It's this one over here. But that's okay. That's what stores what's called the basic input-output system. It's a piece of computer software, very small, that actually tells the higher up software just what exactly is on this board and where you can find it and how to access it. And it gives you basic routines to be able to do stuff. Okay, now, like I said, every computer has to have some memory. Here is the memory on this board. This is called a DIMM, dual inline memory module. This guy right here. This one doesn't have a bunch of memory. It's only got, I think it's only got 256 megabytes of memory, but that just shows you how old this little computer is. Okay. There are usually 4 different kinds of, I sometimes call it memory, but it kind of morphs into storage after a while. And here's how it basically goes, because the point is this microprocessor can go pretty darn fast. And because it can, there is usually what's called cache memory, which is usually a little bit of memory that can be used to, that goes really fast and can keep up quickly with memory on your computer. There's actually a chip that does that here. It's this little fellow right here. This little guy hooks up to this memory, and it's to the processor directly, and it's very, very fast. On most modern processors, like over here, it's actually built into the very same chip that the CPU is. Actually, on this whole chip that you see, the reason why it has to be so big this way is because there's so many pins that have to connect to it. The actual CPU probably only takes up a little bitty bit of that thing. So usually they'll put a chip like this right inside of it so it's even closer to the CPU. The closer it is, the faster it can be. It's kind of weird. It's just like physics. It's crazy. You know, you can't go over physics. Anyway, that's your fastest memory. It's usually static memory because static memory is faster. And it actually uses less power, which is kind of funny, but that doesn't really matter here. This memory over here is called dynamic memory. You have to constantly refresh it all the time. Usually it's not a big problem because you're usually using all that memory usually gets accessed a lot, so it's not a problem, although there are things on here that make sure that it gets accessed all the time. Dynamic memory. This is dual-line memory module. When you see the same thing over here, these things are actually called, I think, they're called DDR memories now. It's still a DIMM, just like this one was, but this one has the double data rate. It just goes twice as fast as what the old standard was, so it's called DDR. We're up to DDR4 now, which is faster, and it's got these little idiosyncrasies. You have to match your memory to your CPU so they can talk to each other. How about that for simple? Anyway, so after that, you go to other kinds of memory. Let me try to pull this one off. Actually, this is a disk drive, although it doesn't really look like a disk drive that you would normally be accustomed to. This is a very early form of an SSD. It's called, which is a solid-state disk. This is actually a flash module that's made to behave like a disk drive, and that's exactly what an SSD is. And this one is 4 gigabytes big, which is very, very tiny these days, but perfectly good for the things of the time. This thing performs exactly the same function as this over here. This is called a magnetic disk drive. You know, you call it a hard disk, you can call it 5 other things, you can call all kinds of things. A lot of computers now have SSDs built into them. They're getting cheap enough now that it's not a big deal to buy them instead of this. This is several magnetic platters that spin around. If you remember records, and most of you don't, records were long gone before you came here. If you think of CDs, they're round and they spin around, and something like a stylus goes across it to read the information on it. It used to be like an old record and a record player. You had a needle, and it would go into a groove, that needle would, and when it went across that groove and you spun it around, it would produce music. Well, this is exactly the same thing, except it does bits and bytes. Well, it does bits. Everything's ones and zeros to this thing at the very basic level. So, we got that little part there. Here's how memory goes. The great thing about this memory, or the one that's on the hard disk drive that you probably are more familiar with, it's long-term storage because it doesn't go away when you turn off the power to the computer. But it's kind of slow, especially compared to the other kinds of memory you have in your computer. So you tend to store files, documents, images, movies. You'll store them on this wonderful little guy, and then as the computer needs it, it'll pull it off of there. It'll bring it into your regular, like, DIMM memory, your dynamic memory, which is faster, so it can all be processed. The CPU does the processing. Don't get weird and say, well, memory does processing. It really doesn't. Then when the CPU needs it, it'll shuffle it into its cache memory, which is really fast, this little guy right here, and then it'll go to the CPU. And it goes out the same way too. It goes from the CPU to the cache memory sometimes. Depends on if it's a read cache or a write cache. If it's both, it goes both ways. And then it comes to this, and when you're ready to store things, it goes to your permanent store of memory. Whether it's flash memory, I'm going to stick this thing back in here so it can do its job properly. It has the same kind of hookup you'd have for a regular hard drive, just like the one over here. Okay, so that's basically everything about the CPU and the memory that's associated with it. All kind of functions as a system. So sometimes we keep it all together, and this is what's called compute. This is your compute subsystem. This is what it takes to actually make calculations to basically make your computer work. Okay, let's talk about input and output. This is really important stuff too. Almost all the rest of this board here, this one right here, is a chip that handles almost all of the peripherals on this one computer. Let me zoom out here a little bit and let you see about it. That one chip handles all these things, and these ports may look familiar to you. This is where you plug in your mouse and your keyboard. Here's some USB ports that you're very familiar with. Here's a network port. It's a serial port. This is a printer port. It's a parallel port. This is for your monitor. It's a VGA type monitor. Here's for sound. Sound doesn't work on this board. I tried it. It's sad. And what it also does is it gives you these buses. Now this is where you can do some expansion. It's very important. Every pin on the CPU right here ends up, or most of them end up coming out right here on this bus. And if you look real close, you can see inside there, and you can see those little bits of copper in there. Those are actually every pin that connects to the CPU over here. That way you can bring it out and you can add cards to it. This is an older version of the bus that was common. This one is one that's a little more modern. And you'll see the same analogs over here on the big computer. Do you see it over here? Okay. This is your regular computer right here. And this is the bus. Almost everything talks to the CPU ultimately through the bus except for memory. Memory goes directly to it. Cache to the DIMMs. They handle themselves. Now, I kind of tricked you because these disk drives, and here's an optical drive in case you guys want to know what an optical drive was. You know this one. It's for DVDs. You'll see the little DVD markings on it. And that's one of your optical drives. It also keeps storage. The great thing about it is you can switch it out really easily. You can take out one disk, put another disk in, and you've got 4.5 gigs of data available to you that you didn't have available to you before. Very important back in the days before we had networking. All right, so let's bring us back to this old one. So we saw all the input-output ports here. And you'll talk a little bit more about inputs and outputs in another video. Okay, and over here there's a power supply. This is the big one on the desktop. It's very large. You plug it in there, and it converts to the kind of power that the motherboard needs. There's the motherboard connector right there for all the power. If you look over here on this other cord, we have the same power connector. But see the power connector? This is the same one that's on that other computer, but there's a much smaller power supply. It's just a little bitty guy. This is made for just nice little applications, small applications. Not very big, not very crazy. Anyway, so hopefully you've gotten a good tour of what is in a computer and how it works. Just a little bit. There's more videos about the actual functions of each bit and how they all tie together. We won't talk much about the management stuff because management usually won't worry about stuff to this level. If you're a manager of people who handle this, your people will handle this. What you're most concerned about typically is speed and power consumption. This thing's very slow. It doesn't put out much heat. That's a nice thing because that's also something to consider. You have to consider cooling as well. This thing consumes very little power. When you talk about green computing, this thing is very, very green. You don't need a lot of power to make it work. But you get the alternate downside that it tends to be slower. Green means slow. Sorry, I don't mean to be rude, but it's true. If you take out all the green features and you do it like this way, which is, hey man, I know I'm going to generate a ton of heat and I'm sucking in a lot of power. This thing is really I'm going to have a big heat sink and a big fan on top of it to keep it cool. That takes a lot of energy, not very green at all. It's just like when you're thinking about toilets. They changed toilets a while back. We used to have big toilets that used to work really, really well. You could flush cats down old toilets. Now today, given the new toilets that we have, which are supposed to be more efficient and more wonderful and better for the environment, and you usually have to flush 3 times to get something down. And that's sad, but that's the way it is. Welcome to the green world. Most of it's been legislated, so there's nothing you can do about it. Same thing's true with computers. If you have a green computer, you got to know a few things about it. It's going to be slower. It's gonna use less power. That's great. It might need less less cooling. You won't need so many fans like this thing. It has one for the CPU, one for the power supply, and then one just in general, just to keep things cool, keep air moving in here. 3 fans in this one. This one doesn't have any fans. One of the reasons why I got it for this demonstration was to help you see all the parts on it. All nice and segregated the way they're supposed to be. Alright, well that's all you need to know about this. Talk a little bit about green computing, talk a little bit about the CPU, the various memory it uses, cache memory, regular DIMM memory, random access memory. That's RAM, random access memory. ROM, the ROM's over here, the read-only memory, which contains the BIOS and some basic, almost a little basic operating system, so that the bigger operating system can kind of latch onto it and know a lot about this computer. I/O peripherals, you got to know about those. And they all connect usually through some kind of circuitry. It's all contained in the chip, in one chip on this computer, before it talks to the CPU. That way everything can move in and out. Your monitor hooks up to this, your keyboard, your mouse, other peripherals you have, the network, and your sound card. Over here it's all in different places and different pieces of equipment. Sometimes they're on different boards. Here's a soundboard. Sorry, it's so dirty. Here's a soundboard that kind of replaced the one on the other one. You can see the outputs over here. That's usually why they have these ports on the end, is for input-output boards. Some of them are very smart, some are quite dumb. This one's on the smart side. Almost every piece in here has its own little computer in it. It's gotten to the point where computers can be made so small and so specialized for each individual application that even a sound card will have a little bit of a computer in it. It takes some of the load off of the CPU. And that's always nice. Over here, you're trading that out for the fact that you're not going to have fans, and you make this as inexpensive as possible. So the CPU actually, through this chip here, actually does all the work for everything. If you need a sound to come out of here, the CPU actually goes through all the work to make that happen. Over here on an expansion card, you won't have that. The CPU can just say, hey, I need this sound to come out, and this card will say, oh, okay, let me work on that, and it'll make it happen. Anyway, I think that's all we needed from the tour. I hope you had fun. I hope it was great. Have a great time, and we'll talk to you later. Bye.